The following content is created by Dr. Avitech. Your support and donation will help me continue to offer high-quality educational resources for free. To make a donation, send an email to 6drcyril@gmail.com or comment donations below.
Welcome back, guys. My name is Dr. Avitech, and in this video, we're going to be finding the Laplace transform of e to the power of something. So let's say we have, we're asked to find the Laplace transform of e to the at. First, remember that the Laplace transform of f of t is equal to the integral from 0 to infinity of f of t e to negative st dt. So now, what I want us to find is the Laplace transform of e to the at. Yep, let's find this one and let's see what it's going to be. So we're going to say this is the integral from 0 to infinity. Now this will then become e to the at, e to negative st dt. So this is what we have. Now what would I do next? These two guys have the same base. Indices, right? They both have the same base. So I can say this is the integral from 0 to infinity. Then this is e. According to indices, I can add up the exponents. But of course, this will become at minus st. Because even if I put a plus here, plus minus will give me a minus. And then dt. So that's what I have. Now, it is important that I do something here to make life easy for me. So this will become integral from 0 to infinity, then e. I'd like to put the minus st first. So this will become minus st plus at. But trust me, it's still the same. It's still the same. And then we have dt. So it's still what? It's still the same. So this will become integral from 0 to infinity. Now take note, this is e. I can factorize out minus t. You can see that t is common between these guys. So t is common. I can bring out a minus t. So this will be minus t bracket. Minus divided by minus, that's gone. St divided by t will give me s. Plus minus is minus. At over t will give me a. Then I put my dt. So this is what I have. Now what I'm going to do next is I'll say I can now integrate this. And remember, to integrate exponentials, what I'll do is I'll write the e. I'll say this is minus t into s minus a. Then divided by the derivative of this very exponent. The derivative here, we're differentiating with respect to t. So this t here is just t to the power of 1. So if I differentiate it, it's just going to disappear and give me minus s minus a. That's what it's going to give to me. So this is minus the t goes. So this is minus s minus a when you differentiate. Okay. So at the end of the day, what I've just done is I've integrated the function. And then I'm going to have 0 to infinity. So that's what I have. Let's do something. I can actually say that this is a constant. So I can say this is 1 over minus into s minus a. Then e, so minus t into s minus a. And then this will be from 0 to infinity. Yep, I can actually do this. And it's still okay. So this will become 1 over minus into s minus a. And then, if I plug in my infinity here for t, everything here will become e to negative infinity. And then minus e to the 0. Remember in the previous video, I told you that this very expression, you're going to see it almost everywhere. So it's just best whenever you get to this portion, just put minus 1 because that's what it's going to end up becoming. But let's continue. So this will be 1 over minus into s minus a. And then we have e to negative infinity will give 0. Then e to the 0 is 1. Because anything to the power of 0 is 1. Now this will become 1 over minus s minus a times 0 minus 1 is minus 1. Now the negatives will take care of themselves. So this means that the Laplace transform of e to the at is equal 1 divided by s minus a. So this is what we have. 1 divided by s minus a. Very, very simple. We're actually done, not kinda. We're actually what? We're actually done. So this is what the Laplace transform of e to the at will give to us. Take note, we're finding all of this so that when we have a particular function, we can be able to tell what the Laplace transform would be without going through this process. That is why we're doing what we're doing. So each time we do this, you try to practice with the function that will found its transform. So in this case, let's practice. Let's take some examples. Now imagine if someone says, what is the Laplace transform of e to the 4t? Now what would this be? If you compare these two things together, you see that a is what? A is 4. So this will just become 1 over s minus a is what? 4. And this is the Laplace transform. You can see that if I know what this would be, I don't need to go through this bunch of things to find the Laplace transform of e to the 4t. I don't need to do that. Next one, number 2. The Laplace transform of e to negative 3t. So this will be 1 over s minus, what is a in this case? Value of a in this case is minus 3. It's minus 3. So this will become 1 over s minus is plus. So that would be s plus 3. Basically, back then in school, when I was still going for my electrical program, each time I have a positive here, this will be minus. I just keep it in my mind that this will be a minus. Then whenever here is minus, I keep it that I'm going to be having a plus here. But be very careful so you do not confuse yourself. Just know the base expression. Whenever you're taking the Laplace transform of e to the something, it's actually 1 over s minus a, which is the number in front of t. Please take note. Another example. The Laplace transform of, let's say we have, this is going to be somehow, let's say we have e to minus 5 over 2t. Alright, so we have minus 5 over 2. So this will become 1 over s. Normally, we have to have a minus from the expression, we have to have a minus, and then minus 5 over 2. So this will become 1 over s plus 5 over 2. But there should be a better way of writing this. Trust me, there should actually be a better way of writing this. Now, if this is 5 over 2, how can I clear a fraction? I simply multiply the numerator and the denominator by the LCM. In this case, we just have over 2. So this is what we want to clear out. So what I will do is I will multiply both sides by 2 over 2. Remember in math, if you multiply and divide by the same thing, you've not changed anything. So in this case, 1 times 2 will give me 2. S times 2 is 2s. And then 5 over 2 times 2 will just give me 5. Because the 2 will cancel out these 2. So this becomes the answer. That's beautiful, isn't it? So let's take one more example. Let's say we have number 4. It's going to be a little bit different. Let's say we have the Laplace transform of 2e to negative t plus 3e to 5t minus 7. All right. It's looking as if it's a tricky one. But here's the thing. The Laplace transform is linear. So what it means is when you have an addition and subtraction, what you have to do is to take the individual transform of each term. That's what you do. So in this case, we're going to take the individual transform. The first one is 2e to negative t plus the Laplace transform of 3e to 5t minus the Laplace transform of 7. Please take note, this only works for plus and minus. It doesn't work for multiplications and all of the rest. And take note, we have convolution here. So when we get to that part, we have convolution in Laplace. So when we get to that part, we are going to solve problems. So let's find the Laplace transform of this. Now, take note, a constant multiple doesn't change anything. In this case, the 2 here is a constant multiple. So I can actually write this as 2 Laplace transform of e to minus t. Yes, I can actually do this. So the 2 can come outside because the 2 is a constant multiple. And then plus here, I'm going to have 3 Laplace transform of e to the 5t. Minus, you can actually bring out the 7, but let's not do that. You can actually bring out the 7. If you bring out the 7, that means 1 will be left here. But let's not do that. So this will just be Laplace transform of 7. And this will become 2. This is e to minus t. Let's be a little bit fast. Do you know that this will become 2 times 1 over s plus 1? Because this is a minus 1. There's an invisible 1 right here. There's an invisible 1 right here. So you're not going to be having s minus minus 1, which then become s plus 1. So you see, that's actually very simple. And then plus 3 times. Now for this case, this will become 1 over s. You have a 5 here, so this will become s minus 5. And then minus, in the second video, we found the Laplace transform of a constant. So this is going to be 7 over s. Now, at the end of the day, what would this whole expression become? Let's see. What would this whole expression become? 2 times 1 will give us 2. So this is 2 over s plus 1. And then plus 3 times 1 is 3. So this will be 3 over s minus 5. And then minus 7 over s. So this is what we have. Now, I don't want to simplify further. Let me just leave it like that. But of course, I can actually simplify further by taking the LCM, but let's just end here. Now with this video, you've been able to see that we can take the Laplace transform of e to the at, and all of these, they are very, very important. Now this will be the end of this video. Let's take a look at the Laplace transform of sine and cosine. Thank you very much for watching this very video. Go to the next one and watch it.